All right, so similar to the last talk, this is a little bit of a prospective talk, and similar to or connection to John's talk is it's going to touch on meta reasoning. So this is work that Stephen and John and I have been doing, and this is kind of a talk about a new problem that is built on the last 3 years of thinking about this problem of constraints. And Stephen's going to talk to you a little bit more in the next talk about constraints, but we've been thinking about this notion of what does it mean to comply with constraints, and especially when we think about constraints that have abstractions associated with them. So what does it mean to comply with laws, for agents to comply with laws? How do you take an abstract situation and ground it in the situation that you're in right now? And then how do you balance the fact that you've got more constraints than you can deal with I got to get something done? And those are questions that we've been thinking about. You'll hear a little bit more about that in Stephen's talk next. But one of the lessons or kind of understandings that we've come to through this is like, if you've got sufficient time to think through these problems, if you're really, really well trained and the domain is narrow enough, if you've got a great instructor that can teach you about it, these problems become a lot less challenging. That the real crux of the challenge is what happens when you're faced with one of these situations. You've got to make a decision and you don't have the prior expertise and knowledge to bring to bear. So that's really our point of departure. And if you think about this from the point of view of the agents that we build today, the agents don't really have a lot of understanding of the world. Maybe as we integrate more language model stuff, maybe as we build larger scale systems, they will. But today, they just don't have that much understanding of the world around them. Stuff that we take for granted, they just don't have. And so part of what we're doing in this project is really, or in this talk, is really kind of think through what is it that you would need to really think through dynamic decision making in an agent when you don't have knowledge of the situation that you're in. So things that might come to mind is like, am I in a dangerous situation? Can I continue with what I was trying to get accomplished? What should I do? What can I do? And then how much time do I have? And those are kinds of questions that you might have in a situation that you didn't understand at all. So we call those out of design scope situations. And your first thought might be, well, that's just a design problem because you didn't think you weren't smart enough in design. And our answer to that is that reality is really unbounded, and especially thinking about general agents, not, a Nest thermostat is a kind of agent, and it's very bounded, right? So you can sort of figure out the situations that it might be in. But as we think about agents with more and more capability that we want to do more and more stuff, they're really going to face these unbounded environments. And even when you can anticipate some things, you might not actually have the resources, the engineering resources to actually plan for them. So our argument is that, agents with a sufficient level of generality and capability that you really want to deploy in autonomous settings. You want autonomous agents that are interacting in some kind of notion of the real world. Real world can be a virtual world. That they're going to encounter situations outside of their design scope. And if you don't buy into that idea, you won't buy into the rest of the talk. But it's really like something that has come up again and again, not only in this project that I just mentioned, but just over the course of my experience, building agents, oftentimes with Soar. This is one of the things that bites you over and over again, is that you just, the person that wants to use the agent wants to use it or apply it in a situation that isn't quite what you expected, and then the agent kind of flails. So the first thing we want to note is just that, well, what does out of design scope mean? And it can mean kind of different levels or different kinds of challenge, right? So one is, I've seen a lot, I understand a lot, and this just happens to be an instance that of a situation that I haven't quite seen the actual dynamics before. So imagine a car that's trained to drive on US roads, and then all of a sudden you're asking it to drive on the Autobahn where the speeds are very different, and it's just never seen 120 mile an hour speeds, right? So that's kind of out of distribution. The next level up is out of design feature scope, which is that I sort of have the capability to respond to the situation, but my prior experience and knowledge hasn't really prepared me for it. So imagine a lane following system in an automotive car that it just never got trained on snow. It's got cameras, it can detect a snow condition, but just never got trained on that. So that would be an example about a design feature scope. And then the last one is the most challenging one, which is just my embodiment does not give me the ability to detect what is really important in the environment. And so that's going to be true in those situations where the agents have limited sensing and limited embodiments, that they're going to face these situations that maybe with our embodiment and our sensing we could understand, but they just won't have the ability to do that. And we like to have solutions that sort of spoke to all of these kinds of situations, not just one. There's a lot of RL work that just is kind of looking at this out of distribution. So I want to sort of present a very sketchy, high sketch, maybe it's sketchy too, but a sketch, a high level sketch of what a solution might look like. So in that top row, the sort of blue, you just got an agent going about doing what it knows how to do. And so it's got some kind of ability to perceive the world through its embodiment. It's elaborating that understanding of the world, perhaps with some internal knowledge, a policy knowledge, whatever that is. It makes a decision to do something, and then it keeps going. And what we would like to sort of give that agent is some very general capability, domain general interpretation facilities that allow it to sort of build up an understanding of the situation beyond its domain knowledge. And I'll talk about some specific examples of that later. And then when it's choosing behaviors, it can choose behaviors according to its existing policy knowledge, and also choose to do things based on this domain general interpretation. And there's some requirements for that. First of all, if you're in an environment where you just don't understand, ideally you'd like to survive. You'd like to be able to continue doing whatever it is your goals were, like working around the situation. You got to deal with the fact that once I expend power, once I move, the world changes. And so you can't just sort of mentally say, I want to go back to where I was before and redo it. And then there's various scaling problems, as well as learning to sort of understand the environment, this new environment that you're in, and improve with experience. So that's kind of the way we look at the problem. There's a lot of people that have thought about various combinations or aspects of this problem, and Stephen is going to beat me up for being a little bit too glib, sorry, but flippant was what I was going to say. But they kind of break down into, I can just find ways to seek more knowledge. I can reason from first principles. Another thing is I can just make an assumption. I don't know what to do here, but I've got good policy knowledge. It's held me in the past. I'm just going to go with my policy knowledge. And then another example, which comes up a lot in physical autonomous systems, is sort of what I call runaway, right? That I can't deal with a situation, so I'm just going to go back to some safe state that I know about. I'm going to abandon my mission. And there's various ways of kind of combining these approaches too. So our question was, which is kind of a question that I do again and again, and thinking about Soars, what do humans do in this situation? And it turns out that there's various theories about this, but one of the things that really we liked was this notion of appraisal theory. People in Soar, Bob Mariner did a thesis on appraisal theory in Soar. But the basic idea behind appraisal theory is that people are continually assessing the situation, and they're generating these assessments of the situation called appraisals that are adding context to the situation. So I'm in a novel situation. I'm in an unpleasant situation. I'm in a situation that doesn't seem like it's helping me with my goals, that kind of stuff. One of the things that we like about these is that they're rapid. They're hierarchical, so they build on one another, which means that you kind of get a more complex, a richer understanding of the situation as you think about it a little bit more. And they're not completely knowledge. They're not independent of knowledge, but they're very knowledge lean. You can kind of come up with these people come up with these appraisals in situations where they don't have a lot of deep knowledge about the situation. And then what the appraisals do, that like I said, the main thing that people generally think about them is that they're a precursor to emotion, and they also can help you with certain kinds of what's called an action tendency, flight or fight, but also like I'm open to this experience or I'm closed to this experience. So there's sort of communicating your stance towards the world. So now, if you think about this situation, think about it. Now you're not, the robot's not here, you're here. And so what are the, if you really kind of immersed yourself in this picture and thought about it, what's going on in your mind, right? This is a situation that you don't really know. You know, ChatGPT made it up, so I don't know either. You know, are those eyes or did they just look like eyes? Do those things move? If you watch for a few seconds, you would kind of know. And so you're kind of looking at this situation, trying to recognize it. Is it pleasurable? Is it painful? Is it going to hurt my goals or not? And so forth. So this is the kind of thing that human appraisal is, you know, the evolution has designed to do. So we're not really so interested in the emotional side. We're really interested in this functional side. And the really important thing in the connection to John's talk to some extent is that we want to think about these appraisals as a source of meta knowledge about situations that can inform how you might choose the decision-making strategy that you're going to take. So it's an input to a meta reasoning process. And yeah, so I guess I'll stop there. I'm gonna run out of time, so I'm gonna stop there. And if you want to talk about more about that, we can.
Joe agreed with you.
Oh. So this is our sort of very high level notion of how this might work in practice, where there's a process going on somewhat in parallel with regular Soar, computing these appraisals. As I mentioned, they're hierarchical, so you kind of start with, is this relevant to me? And you go all the way up to, you know, how is it normatively significant to those around me? And then based on the appraisals, you're making a decision about what kind of decision might I make. So that's our vision for where we'd like to go. The nuggets here are like, once again, kind of human technology seems pretty insightful for thinking about, you know, a really hardcore problem in autonomous agents. I find this particularly an intriguing problem because if we look back at this picture, you know, it's not completely interesting how to do this in Soar. Maybe the answer is it's all, you start in a developmental kind of story and you learn how to do this so that it's not really parallel, that's all happening serially, but it's happening really, really fast because you chunked it all up. And then there's also the question of if some things are architectural, we haven't really thought about knowledge-mediated architectural processes. So what would that look like? So there's some pretty interesting architecture questions here. It's a big problem. So one of the calls here is we've got to figure out exactly where to focus. There's a large body of related work. I mean, really huge amount of related work. And so there's a question about how to differentiate what we're doing. And then lastly, we want to test these systems in situations outside of their design scope. So you're going to trust me to test my system outside of the design scope that I define. So there's a methodological kind of meta research problem here too that we don't have answers to today. So I'll stop there. That's 12 and a half minutes and see if there's time for one quick question. Jim.
This is probably a dumb question. How does the system know it's got a problem? Is it because it doesn't get to the next task step, or?
So one of the challenges, I didn't mention it too much here, but one of the challenges, which is similar to I think one of the questions James got, is like, what are the triggers that's going to tell you you're outside of a normal situation? So right, if you have good models of the world and then you sort of experience something that doesn't fit your model, that's a pretty good trigger. And that might get mapped onto an impasse in Soar or something like that. But like if it's one of those things that's really outside of your ability to perceive, I think the example that I had was like you're driving a car in Iceland and the car doesn't have the ability to detect heat. So like you're on a road with lava on it, but you don't actually know because you can't detect heat. Then that's a different recognition problem, and that will be a hard problem, I think.
I have a question for you if there's time.
Sure, Stephen, why don't you come on up and
Can you hear me?
Yep.
Just real quick regarding about being able to identify problems. Have you thought about maybe using, because I know like with some systems they use sensors that pertain more to pressure and temperature and also other things besides just vision. Have you thought about maybe incorporating that in what you're doing?
Yeah, I mean, so I think that the point that we were hoping, like there's an engineering question for a particular autonomous system, what set of sensors does it have, right? So there's a whole debate about, do you need LiDAR on an autonomous car or not, right? So Tesla's taking one path and most of the rest of the world's taking another path. But I think that part of what my perspective is that there's always going to be things that you could encounter outside of your embodiment, whatever it is, right? We can't detect UV. And so there's things that are happening in our environment that we can't detect. And it's not so much that any particular embodiment is going to have those issues.
Okay.